Hi, we're back with a new section of this course, Binomial Heaps. In this section we'll look at one more popular heap implementation, namely a binomial heap. We'll begin with an introduction to binomial trees. Next we'll see how to link two binomial trees, the basics for growing a heap. Next we'll look at how to merge two binomial heaps. Finally, we'll look at how to find and delete a minimum element. Now we move on to the first video of this section that deals with binomial trees. In this video we'll observe the tree structure and see how to represent a tree as a binary tree, with the left pointer pointing to the first child, and the right pointer to a sibling node. A binomial heap is a collection of binomial trees, giving us a very efficient heap merging operation. Now, the next question which may arise in your mind is, what is a binomial tree? So, it's a recursively defined tree, as you can see in this figure. The first binomial tree has just one node. Its height is equal to 0. A binomial tree of height 1 is formed from two binomial trees, each of height 0. A binomial tree of height 2 is formed from two binomial trees, each with height 1. The tree is defined in terms of itself, recursively. For example, the following figure shows two binomial trees of rank 2. When the right tree is pulled up, the left tree becomes its left child. The resulting tree is of rank 3, with 2 raised to 3, which is equal to 8 nodes. The structure is formed by similar, smaller structures, as depicted in this figure. The definition of binomial trees could also be stated as: a binomial tree with a rank k is composed of subtrees with rank k minus 1. Here's a pictorial way of stating this. This forms an important basis for the merging operation, as we'll soon see. You can also look at a binomial tree as a list of binary trees, as illustrated in this figure, which shows a binomial tree of rank 3. If we leave out the top node, we have binomial trees of ranks 2, 1 and 0. How could we express the previous data structure? For example, what is the canonical way of representing n children of a node? Consider you want to represent a tree. A node in a tree can have any number of children, and each child can have a number of children of its own. One way is for each node to hold a list of its children references. This is a straightforward representation. We wish to hold references to n children, and, as there is no limit, we can simply employ a list for holding the children. Here's how it would look pictorially. However, there is another representation, namely representing a tree as a binary tree with the left pointer pointing to the first child and the right pointer to a sibling node. Here is how it would look like. This is a better representation, as we don't need to waste space for the array holding the children pointers. In this video we've explored about binomial trees.